Alright, this is the 4th time I'm doing this video. Make sure you know that I have spent 4 hours of my time making these videos because you need to have a lot of space. So for next semester, if you want videos, I will be taking donations of flash drives to make them because it's taking up too much space on our hard drive. Alright, so here we go. 32, la la la, look at everything I did. Okay, set tan x equal to -1, and I wound up having 2 spots where I'll have a -1 for tangent, which is 135 and 315, but it has to be in radians, so you see I changed it to radians. And this is 7 pi over 4. Alright, here I factored, found 2 things that multiplied it to and add to -3, so that was -2 and 1. Repeat the 2x twice because one of them will wind up reducing. So as you can see here, everything has to be in radian form by the time you're done. So 1/2 shows up on the unit circle at 30 and 150. So these are in radians, and sine is 1 at 90 degrees. So that's at pi over 2. So look at that. Alright. Now we're to the calculator section. Make sure that you know when to use radians in your calculator and when to use degree. So this is radians. So we have here 6 inches times pi over 4 because it's r times theta, which gives you 3 pi over 2. And then the next one is 15 pi divided by, because you're already given s. So you do 15 divided by 5 pi over 6. And then you can do 15 times 6 is 90, cancel out the pi's, and you're left with 18 feet. And then here you just divide 30 divided by 10, and you get 3 radians. Make sure if you're looking for the angle, you write radians. You don't have to do anything with pi. You don't have to divide by pi. You don't have to do any of that stuff. Just write the word radians. Alright, favorite problem in the world. Pendulum problem, ball, a string problem, whatever they call it. It's really easy because they give you the whole period. It goes from 0 to 6, so your period is 6, making your b pi over 3. Starts at t equals 0, so that's c equals 0. And then you can find your a and d using the formulas, either high minus low or high plus low over 2. Alright, you look here and you see that here is the equation. And you would place that equation into your calculator, but you know you could graph it by hand. So when you put in your calculator, just make sure these are you have to change your window. So your window should go to like 0 to 7, and then from like 10 to 170 for that one. Alright, so I'm not going to show you the calculator for everything, but I will show you here that to find this answer, you can go to second graph, which is the table, and see where x equals 5. And that will tell you that it is at 125 feet. You can also, this is a different example, this is not the same example, but you can also press trace and then press 5 and it'll give you the answer. Like I said, this is a different example, but that's how you can do it. And then for the next one, they said, what is the value the first time the ball's at 40 centimeters? So you would make sure that here at y2 you would put in 40 and then press second trace number 5, and I will show you more detail on that with number 36. Alright, so there are your answers and some guidelines on how to get part C and D. Alright, 35, Ferris wheel starts high, ends high, so we have a regular cosine graph. There's the equation. We start at time 3, so c is 3. Your period has to be doubled. Well, the time has to be doubled for your period because this illustration only told you that we went from a high point to a low point, but in order to have a full graph, you must go back to the high. That's why you do 7 minus 3 is 4 times 2 is 8, making your b value pi over 4. Alright, again, this is a different example. But you would put everything in here, and then if you're trying to find out t equals 11.5, you can trace it. Just press trace and then 11.5 and press enter. Like I said, this is a different example. It's not going to be the answer you see here, but that's how you would get that answer. Now if you're going to do, they said the first 2 times that you hit 70 feet, make sure that you put 70 here for Y2, and then you'll press second trace number 5, which I will illustrate for you in a different example. But these are the 2 answers. Alright, last but not least for this section is number 36. So here's a little idea of what kind of a problem it's going to be. You can tell I'm tired. Alright, you see the name of it. So it's a dock of the bay, and what you're going to do is make sure that midnight is times 0, because midnight is really the start of the whole hour. So from midnight to 1 is 1 hour, so we're going to call midnight times 0, which means that our C is 0. If it was noon, that's a different thing, and noon would be 12, because noon is 12 hours after midnight. So C is 0. Your period is going to be 630, or 6.5 minus 0 times 2, which is 13, making your B 2 pi over 13. And then your A and D, you know how to get those. So here is your equation, and this is the equation I'm actually going to illustrate. So you have your Y equals, and then here's your graph. Now I have a 3 here because part B is asking about 3 meters, so that's where the 3 comes from. And here's your graph. So it wants to know the earliest possible time. So here is the earliest possible time. So what you're going to do is press second trace number 5, and you want to try to get as close to that earliest possible time as possible. Now it's going to take a little while, so you can just press the down button and it'll bring you closer. And then just press enter 3 times, and you wind up getting 1.74. Now that's the decimal representation of time. So we want to change only the decimal, not the 1, because the 1 is the hour. So we want to know how much time in minutes was 0.74. So you just do 0.74 times 60 and you get 44. And that means that at 1:44 a.m. is the earliest time that we hit 3 meters. All right, so now for a little mood music.
Sitting on the dock of the bay, watching the tide roll away. Ooh, sitting on the dock of the bay, wasting time.
All right, good luck, everybody.